Guys, for the next probably three days, maybe even 4, I'm not sure. We're going to talk about a very important type of question in calculus, which is position, velocity, acceleration questions. In your guys' blue books here, you'll see the ones say you see the part says particle questions, but it comes up in other places too. But basically, it has to do with objects that are moving, and you have to answer questions about where they're located, how fast they're going, what direction they're moving, is their speed increasing or decreasing, etc. It's a very important type of question, so that's why we're going to spend so long on it. It was for this topic, this sort of stuff, that Isaac Newton invented calculus. It was to solve these problems. So this is what actually, this is calculus's birthing ground. This is where it comes from. So let's go ahead and get down to business here. So first thing I want to chat about, and you guys, I printed a lot of this for you. I'm going to pass this around. I forgot to do it double-sided, though, so if you want to staple your stuff together. All right. Quiet, guys, quiet. Okay, so let's talk about the position function here. A position function is basically a function where if you plug in some specific time value, it will tell you the position of the object at that time. Okay? So that's what a position function is. So for instance, if I were to give you guys something like this, what that means is let's say that t is in minutes, and let's say that the position, let's say it's being measured in centimeters. I don't know. Just making stuff up here. What that means is at 3 minutes, whatever object we're talking about, after 3 minutes, it's at a position of 180 units. Okay? Now, what do I mean by 180 units? Well, in this class, we're almost always going to be talking about this stuff in terms of where it's located on an axis, like either an x-axis or a y-axis. So, you know, if we were talking about a vertical axis, then at 3 minutes, it would be 180 spaces high. Okay? So that's what a position function is. It's a function that tells you the position of an object at some particular point in time. All right? Now, you guys know that delta means change, okay? So an object, if it goes from one position to another, then you can say it has changed its position, correct? And what delta S represents is how much it has changed. So what you do is you take the second position and you subtract from it the first position, and that will tell you how far apart they are, which you can write like this also. And we call that delta S. That basically just tells you how much the object has moved. Okay? But something that's kind of important is it also tells you what direction it's moved in. Okay? So for instance, let's say that an object was at coordinate 10, but after a few minutes it was at coordinate 50. So it went from 10 to 50, right? So position 2 is what? And position 1 is? And we get a value of 40. That means the change in the position was 40. Okay? Now, since that's a positive, that means its change in position was a positive amount. So if you're on a vertical axis, that means it went up. If you're on a horizontal axis, that means it went right. Does that make sense? But what if I told you that the object used to be at 50, but then it was at 10? So it went from 50 to 10. Well, then it's going to be 10 minus 50, which is negative 40. So that means it either went down 40 spaces or it went left 40 spaces. So the sign tells you something, which we're going to chat about in just a second as well. So So there it is. So if we're talking about a vertical axis like a y-axis, and you have a positive position, that means you're up there somewhere above the 0, right? If you have a negative position, that means you're somewhere down below. So 0 might be in the middle, right? Positive s's are up here, negative s's are down here. A positive delta s means that it's moving up. So if your change in position is a positive number, that means you're going up. If you have a negative delta s, that means your object went down from one position to another. Okay? Same thing kind of applies to horizontal axes. If you have a horizontal axis, positive s is on the right side, negative s is on the left. And if you have a positive delta s, that means that your object is moving to the right. But if you have a negative delta s, that means your object is moved to the left. Now, distance is related to delta s, and that it's the absolute value of it. So remember the example I gave you where I told you an object was at 50 and then it went to 10? What was the delta s for that? It was negative 40. That's what we would call the change in position, okay? Delta s. But if I asked you for the distance, distance is the absolute value of that, which is just 40. It's kind of like back in geometry. You guys know that when you're dealing with shapes and stuff, we don't have negative numbers, so distance is always going to be a positive thing. Okay? So at this point, I'm going to throw some questions at y'all. Okay, so example, well, strange. Okay. I don't understand. Example 1. All right, so let's say that we have some dude out taking a stroll along a horizontal path. He can go that way to the right, or he can go backwards to the left, whatever. Let's say that 0 is where his home is located. Okay? And we're talking about the path that he's traveling. So, first of all, number 1, I'm going to give you guys something here. I'm going to try to make these numbers a little more realistic than I did last block. Let me see. Uh-huh. I know, yeah. I haven't given that. Thank you for asking. You're already ahead of me, you know. I'll tell you in a second. Okay. So, I want us to interpret this, but before we can, we want to make sure that we know what our units are, and that's what Marcos was asking. So I'll pause here. Okay, so I want you guys to interpret this. So, what does this mean here? This first one. Close. At 1 minute, I don't want to say he's traveled 30 yards. He's at the 30-yard mark. So let's write this. At 1 minute, he is 30 yards to which direction?
Right.
To the right of his house. That's what that means. At 30 yards, at 1 minute, he is 30 yards to the right of his house. So what does this next one mean? There you go. So at 5 minutes, he is 100 yards to the left of his house because it's a negative 100, right? Okay, so let's ask another question then about this. Find delta S on the interval Find delta S on the interval from 1 to 5. So what does delta S represent again?
The change.
The change in position. And the way I told you guys to do that was to do f of t2 minus f of t1. Now what's our second time? What's our first time? Okay, and what was f of 5? And what was f1? And so his delta S was, now what did I tell you that means then whenever an object has a negative delta S? Let's interpret that. Huh? Yep. So let's interpret that now. So he moved 130 feet to the left on the interval 1 to 5. That's what that means. He moved 130 feet to the left on the time interval from 1 to 5. Okay? Yeah. Oh, dang it. You're right. Thank you. Did I do that anywhere else? That matters, you guys. That will cost you a whole point on your FRQs if you screw up your units, just so you know. All right. So he moved 130 yards to the left. Okay. So number 4. I want to throw another question at you. What distance did he travel? This is going to seem like a stupid question, but just bear with me. What distance did he travel on the interval 1 to 5? And what's the answer? Close. There we go. So, distance, notice here, I'm not going to say, distance doesn't tell you which way he went. Okay, it just means how far apart are those two locations. So we're not going to say he moved left, we're not going to say he moved right, and we're not going to put negative anymore either. Distance is the absolute value of your change in position, and all it tells you is how far apart your first position was from your second position was the absolute value of that. Okay, so that's position functions. Okay, but I want to show you another way, and this is a weird way to present it, but I like presenting it this way because it's a little more tangible because we're thinking of a guy moving. But really, I'm going to show you how the questions are typically presented. So let's go ahead and take a look at a second example, and then I'm going to throw a practice problem at you guys. Are you guys talking to me? It's due tomorrow. That makes it less my problem. Tell the sub. All right, guys, here we go. We're not going to do units on this one. And a lot of times on particle questions, they don't, but I'll probably throw them in sometimes just to practice it. Just the answer, yeah.
Oh, just the answer?
Yeah. I'm glad. I like how you're focusing on units so much because that is very important. But for this one, I'm going to go ahead and skip over it. So it says a particle is moving along a vertical axis. That's important to pay attention to. According to the function f of t equals t squared minus 4. Now what this means is that you can find the position at any time by just plugging in the time. Now, this problem is asking me to find delta f of t. Now f of t is just another way of writing the s, right? So I want to find my what? And what does that mean? I want to find my change in position on the time interval of 4 to 7. So the first thing that we need to do, you guys, is we need to find out what is f of 7. And then we need to find out what f of 4 is. And then we need to subtract them. Say what? All right. Let's do it. Hey, Manny. So my function is t squared minus 4, right? So this is what I would do if I want to plug in 7. And then I also want to do the 4. So 45 minus 12 gives me what? Gosh, you guys already, you said that like a minute ago. I'm going way too slow for you guys to say, oh well, it is what it is. Okay. All right, now I have a question for you. Let's add this question. Write it down, don't say it yet. What direction was it going? Okay, I'm sorry. You guys say it out loud now. What direction? Up.
It's up. It's a vertical line.
Now, why are we saying up this time? Because it's moving on a vertical axis. Vertical axis. All right.
I just turned off gravity.
All right, so let me throw student practice at you. I know you guys have got this, but I'm going to go at the same pace as I did for first period because. Okay, so this time I'm going to throw some units on here, you guys. Go ahead and answer the question I'm going to put up here in just a second. But after that, we're going to use this to kind of catapult into the next part of our lesson. So don't, make sure you guys, I would write this down. So we'll call this one, find delta F on the interval 2 to 8. What direction was it traveling on that interval? Oh well. And we'll leave it at that. So, Jacob, what do I do first, bud? Huh? Do you know what to do first? Did you think about it at all, or no? Good. So we want to do f of 8 minus f of 2. Good. That's good enough. Thank you. All right. How's about Akaya? What did you get for f of 8? You didn't do it? Is it negative 11?
Yes.
And did you do f of 2? So that's the answer to A. Roxanne, what direction was this object traveling then? Left. Okay. Now, here's the thing, guys. I wanna make sure that I phrase this correctly. What direction was the object traveling? There's kind of a technical issue here. Don't you guys agree that it's possible? On this problem, this is not what happened. It definitely only went left. But don't you guys agree that it's possible that something could have went to the right, then left, and then right again, and then left again, right? So it could have done a bunch of back and forths, right? So whenever I say what direction was it traveling, I think a better way of saying it was if you compare the first position to the last position, which direction did it move? Ultimately, it went left, right? But I don't want you guys to think it only went left. It could have been wiggling along the way, okay? So just so you know and you're aware of that. But on this problem, it didn't wiggle, and I won't tell you how I know that right now, but it definitely only went down to the left. So, all right, so now I'm going to use this problem as a platform to introduce our next concept. So now I want you guys to ask this, and I'm going to give you about maybe a minute or two to figure this out. I want you guys to figure out how fast was it going. How fast was it going? Now, just for you non-physics people, you may already be common sense to you, I don't know, but just in case, if you don't know, speed is how fast, right? Speed is distance over time. So I'm going to give you guys like a few moments here. When you guys answer this, I would like you to include units in your answer. Include units in. How fast was it going, Nikaya?
2. Well, 2 to the left.
That's good. 2. So the speed was 2. Now units. Do you got units for me? Okay. So So how did you get that, Nikaya? What did you do? Okay. So what does that 12 represent? The distance it traveled? Now, if you want to call it distance, we need absolute value. So I agree with you, but let's just take absolute value. Don't you guys agree distance was absolute value? Okay, so now that's the absolute value of negative 12 is 12. Now that's 12 what? That's inches, right? And what's this? Now, where'd you guys get 6 from? Because I don't see a 6 anywhere up here.
They gave us a time interval of 2.
That's right. We're going from 2 seconds to 8 seconds. That's a transition of 6 seconds. You guys agree? So basically, I traveled 12 inches in 6 seconds. Now, if you reduce that, that's 2 inches per second. That's the speed. Okay? Now, what I'm going to talk about next is velocity. Now, velocity is pretty much speed, so I wanted to connect it to something you guys are familiar with already. You guys understand speed well. But velocity is slightly different. The only difference between velocity and speed is this. The speed is 2 inches per second. The velocity is negative 2 inches per second. And all that means is that we don't do distance over time, we do change in position over time. Okay? Oh, displacement. That's so change in position, the fancy word for that is displacement. Yes, displacement. Displacement over time. Okay? So you just don't do the absolute value. That's the only difference. So let's continue here. All right. Ooh. All right, guys. So let's return to our notes for a second here. Let's return to our notes. Now, I want you guys to understand this. We're finding average velocity because, once again, all we have is a starting point and an ending point. We really don't know what happened in the middle. The speed could have been changing. All we have is the starting amount, the ending amount, and that tells us an average speed. So really what we found was the average speed. Okay? Average velocity. Well, that's the same thing as average rate of change, you guys. It's just basically a slope. So what we do is, to find your average velocity, you do your change in position, which Marcos was kind enough to remind us, that's called displacement. You take your displacement and you divide it by the change in time. In other words, delta S over delta T. I put my delta in the wrong spot there. Sorry about that. Now, how do you find your change in position? You just do F of T2 minus F of T1. And I've got my numbers backwards there too. It's nice to have typos. And that's just our slope formula, right? That's all it is. So average velocity is average rate of change. It's just you're doing average rate of change with a position function. And that's what velocity is. So velocity is the average rate of change of position. It's the slope of your position. Now let's go back to our example. I'll prove it to you. What was our average rate of change here? Or what was our velocity, I should say? It was negative 2. What's the slope of this line? There you go. Velocity is the slope of position. Or, to say it in calculus words, it's the average rate of change of position. Or, if you want to get even more calculus-y, which we will later, it's the derivative of position. Okay? We'll get to that. Okay, so there's that. And what we also saw was that the units for velocity is the units of your position over your units of time. So it's always going to be something per something. It's the units of F over the units of T. Yeah? No, you. You could just say that's the slope, right? But yeah, but that's not normal. They typically won't do that. But it will be. Yeah, because we apply the limit. No longer will be an average, but there will become a. You got it. All right, here we go. So, here we go. A positive velocity. Positive velocity. Well, it's positive because the change in position was positive. So if you have a positive velocity, that means it was moving up or up, right? If it's negative, that means it's moving down. That's if you're on a vertical axis. But if you're on a horizontal axis, positive means the object is moving to the right or it moved to the left. Okay? Now, here's an interesting fact. I think I might have already said this, but speed, you guys remember how I told you that distance is the absolute value of displacement or change in position. Remember that? Well, speed is the absolute value of velocity. That's it. That's it. So let's go ahead. I think at this point we're ready to move into an example here. So another example. Yeah, we're not going to acceleration today. No acceleration today. Okay. So find this example in the notes that I printed out for you guys. Okay. A billiard ball is dropped from a height of 100 feet. They're telling you your units there. The ball's height at time t is given by this position function. Find the object's height at 1 second. So our time units are going to be in seconds, just so you guys know. Okay, so how would I find the object's height at 1 second? Plug 1 in. That's your position function, right? So if you plug in your time, it will tell you the position at that time. So let's do it. What's that going to be? $84 what? Okay, guys. So what this means is after you drop the ball, after 1 second, it went down to 84 feet off the ground instead of 100. It was at 100. 1 second goes by. Now it's at 84 feet off the ground. All right. Let's go ahead and find the object's height at 2 seconds. So now I'm going to plug in 2. Good. So 36 feet. Now I want to find the object's average velocity on the time interval from 2 to 1. Okay? Now, velocity is position, the change in position over the change in time. Okay? So, what two time values am I looking at here? So, my second time is 2. My first time is 1. So what was the position at 2? We've already figured it out. It was 36 at 2 seconds. What was the position at 1? And this will be 1 on the bottom, right? And what's 36 minus 84? I think it's negative 48. Now we need units though. Okay? That's negative 48 what? Good, because these are feet on the top, right? These are seconds on the bottom. So this is negative 48 feet per second. So that means the object, on average, this is an average speed, because actually, I don't know if you guys know this, but gravity causes things to go faster and faster. Okay, so really there's not just one speed here. It just, like if I let go of this pen, the initial speed is 0. But as soon as I let go, it starts slow and it goes faster and faster until it hits the ground. So there's not just a speed, but this is the average rate of change, the average velocity, the average speed, okay? What is the object's average speed then? Positive 48. So, answer to C is negative 48 feet per second, and that means the object is going which way? Down. In this case, down. It could mean left, but in this case it means down, because we're going on a vertical axis here. And the speed is just 48. We don't care about direction with speed. It's just a number. Okay, so there's that. And then I'll throw one of these at you guys, and that's unfortunately where I'm going to stop it for the day. I wish I could go further, but we're out of time. So I want you guys to find this object's average speed on the interval from 0 to 20.